In this video, we are going to look at the transformations of exponential functions using the table method. There are two examples we are going to look at. For both, we are going to identify the base function and describe the transformations. And then we're going to use the original table of values for the base function. And using the transformations, we're going to make a table of values of the transformed points. So in the first question, this is the equation with the transformations. So the base we see is 3. So that means the base function is y equals 3 to the exponent x. And this table is given to us. And I just went from -1 to +3. And those are the corresponding y values. So now we will identify the transformations. There is a negative in front of 3. So that means a is -1. Then we look at the exponent. X is being multiplied by 2, so b is 2. Then we see we have x plus 1, which means h is -1. And just a note, this is in proper factored form, so we don't need to do that there. And then finally, we see that we have a plus 5. So that means v is equal to 5. So a is equal to -1, which means that there is a reflection in the x-axis. B is equal to 2, which means there's a horizontal compression by factor 1/2. H is equal to -1, which means there's a horizontal translation 1 unit to the left. And V is equal to 5, which means there's a vertical translation 5 units up. So I've written those descriptions here on the right, and now I'm going to apply them. So the first thing I will do is apply the B and the H values to X. So I have X, because it's being compressed by a factor of half, that means all the X values are being divided by 2, and then they are moving 1 to the left. So for each X value, I'm going to divide it by 2 and then subtract 1. So when X is -1 divided by 2 to get -1/2, subtract 1. So you would find a common denominator, so that's -2 over 2. So that would result in -3 over 2. The next 0 divided by 2 is 0, take away 1 is just -1. Next, I have 1/2 take away 1. So again, I'd find a common denominator. So 1 take away 2 is -1 over 2. The next one, 2 divided by 2 is 1. Take away 1 is 0. And then finally, 3 over 2 minus 1. Again, I need a common denominator, so I get 1/2. And now I will apply a and v to my y values. So the y value is being multiplied by -1, and then we are adding 5. So for the first one, I have -1 times 1/3, which is -1/3. And then I'm adding 5, so I need a common denominator, so that'd be 3, so it's 15 over 3. Add the numerators to get 14, so that's 14 over 3. The next one, -1 times 1 is -1 plus 5 is +4. The next one, -1 times 3 is -3 plus 5 is +2. The next y value, -1 times 9, to get -9 plus 5 is -4. And then finally, -1 times 27 is -27 plus 5 is -22. So the table is now complete. Each pair represents the x and y coordinate of a point that you could plot and then connect those points to show your transformed graph of this base function. So again, the first table are the x and y coordinates for your base function. The second table are your x and y coordinates for your transformation function, your transform function. And we get these new x and y's by applying a, b, h, and v to your original points. And remember, in general, x is being divided by your b value because b is the opposite. So here when b was 2, we're actually compressing by a half. So we're dividing by 2. And then we add h. And then for your y, you multiply it by A, and then add V. So this is in general what we are doing. And remember, to get full marks, you need to show these title headings. The second question, we have 3 times base 1/2 to the 1/2 x minus 4. We see the base function is this 1/2 because this exponent is on that base of 1/2. So the base function, I would write it as y equals 1/2 to the x. Again, this first table are the corresponding values of when we substitute in for x what we get for y. So when x is -3, 1/2 to the exponent -3 gives us 8, and so on. So now we are going to identify a, b, h, and v and describe them. So a is 3, it's being multiplied to the base, and then in the exponents, we have 1/2, which is being multiplied to x, so b is 1/2. And then we have an h value of 4 because there is x minus 4, and there is no v value because nothing is being added. So a is equal to 3, which is a vertical stretch of factor 3. B is equal to 1/2, which is a horizontal stretch of factor 2, again, brackets of lies. H is equal to 4, horizontal shifts 4 units right, and V is equal to 0. So now I will apply these to my x and y values. So for x, it's affected by b and h. So x, and we are going to divide by b. So I'm dividing by 1/2. You might want to rewrite this as x divided by 1/2 when you have a fraction within a fraction. Write it this way, it's a little easier to see. And then when we divide, we actually multiply by the reciprocal. So that's 2 over 1. So then that just becomes 2x. So up here in the table, I'm just going to write 2x. Also remember, it's a horizontal stretch of factor 2. So we are doubling the x values. That's why it's 2x. And then we're going to add 4 because the values are going 4 to the right. And then we apply that for each of these x values in our base table. And you get the following: -2, -4 plus 4 is 0, -2 plus 4 is 2, 0 plus 4 is 4, and 2 plus 4 is 6. And now we will apply a and v to our y values. There's only a, so a is 3, so we're going to multiply y by 3, and then if you want, you can say plus 0 because v is 0. And now we will apply those transformations to each of these y values from our base table. So 3 times 8 is 24, 3 times 4 is 12, 3 times 2 is 6, 3 times 1 is 3, 3 times 1/2 is 3 over 2. And that completes our second table.